Hello, my name is Charles Burnam, and I will be sharing my action research study. My study is highlighting the integration of technology in math classrooms. I'm currently working in Jefferson County at a sixth grade academy school, Frost Academy, and our students' demographics show a need for an intervention program to assist in students' reading and math skills in addition to what we are already using to help improve student achievement. The intervention program that we are using is Study Allen, which is a web-based instructional site that helps improve students' reading and math skills. So I will be doing a comparison of students' fall and spring math scores and obtain the time each student spent on Study Allen to see if Study Allen played a difference in students' achievement, whether increased or made any difference at all. So my research study question is, how does the use of Study Allen promote middle school mathematics students' understanding and attitudes while solving mathematical concepts? Here are the three different ways that technology can be integrated into a classroom. It could be used in an exploratory environment, as a tutorial, and tools. And here are the definitions and the sources that breaks down each form: exploratory environment, tutorial, and tools. Here is a breakdown of my themes. One of my themes, the different mathematical web-based instructional resources that are currently used, and the three that I highlight are the Map Learning Companion, Computer Supported Collaborative Learning, and Math Explorer. The first one basically helps students with learning disabilities. It's a computer-based program. The second one is a strategy for students to team up in an online environment and work on virtual math teams to discuss and solve problems using an interactive and shared whiteboard. And then the last example that I share is Math Explorer. And this program uses 4 cognitive strategy steps: reading, finding, drawing, and computing, which all 3 are used to help increase students' understanding while solving math problems. Here's my other theme: the impact of student technology has on students' achievement. And one source in particular that I would like to read is by Christian 2016. And she reveals that web-based mathematics assessment and practice enabled participants who had a high level of anxiety in learning math to recognize their scores instantly. Thus, they had more control over their learning and felt less anxious about doing math. I thought that was very important because a lot of my students, at least, have shared the anxiety that they feel, and that can lead to discouragement. And so, Study Allen definitely provides students the additional practice time. They can reread the steps, reread the notes. They can practice and correct their mistakes, even see their mistakes. And then next we have a summary again of my goals, the sources, and the themes. So while exploring the different web-based instructional sites, it's good to explore what's out there so we can collaborate, network, and share with others. And here's my table, continued. So here is my data confidentiality of human subjects. So again, I'm using 64 sixth grade students and 4 math teacher. I will be using an Excel spreadsheet to store students' identification numbers and their fall and spring math scores. I plan to protect my data results by encrypting the file with a password. Also, I sent home a backpack note for students to gain permission from the parent or guardian in completing the survey. So my methodology and procedures. So my action research applied a group comparison in the form of mixed methods, qualitative and quantitative data collection. For my qualitative data, I will be using the students following spring math scores, and for my quantitative data, will be in the form of Likert surveys. I would administer surveys to the math teachers at my school and a sample of 64 students out of a population of around 550 students. So my procedures are as following. First, I administered the backpack note to my students so they can so we can give them time to have their parents to review it, and then if they could not complete it, then they'll just bring the note back. So I had to give them time. So my first step in my process was administering the teacher surveys, and then I I was able to obtain my students' scores. And then the last step in my process was students to take the survey. Here are my descriptive statistics. Right here is my fall map scores. The red line represents the median, which was at 196, and 32 out of 64 students scored above the median. Here is a table, a graph of my spring map scores. And right here again, the red line represents the median. And my median had increased from 196 to 200, and this time 54 students out of 64 scored above the median. So we had an increase of 4 points, and 22 more students scored above above the median. Right here is a bar graph of the student growth scores. So as you see we had more students, around 24 students scores to increase between 5.7 points and 12.6 points. And and then we had at least 18 students who also scores increased or decreased a negative point. So overall, again, we have student growth. Here are my student survey results, and 58% of students felt like Study Allen helped to reteach the math concepts that was challenging. 74% of students felt like the feedback provided from Study Allen within the lessons was helpful. 35 students felt like Study Allen did not improve their skills, and 52% of students felt like Study Allen was engaging. And for my teacher survey results, all 4 teachers answered either strongly agree or agree for the following. Study Allen improved students' understanding of various math concepts, helped to improve their confidence in solving math problems, and helped identify struggles that students had while solving math problems. So overall, the surveys showed a positive outcome from using Study Allen in math classrooms. Here is my data collection and analysis. I included a p-value table and a correlation table, and my p-value was very, very low. It was less than 500ths, which indicate that the growth that was shown did not happen by chance. And the correlation table shows a weak correlation in regards to the time students spent on Study Allen and their scores. So my correlation was 30 hundredths, which is rather low. So that tells us that more time spent on Study Allen did not necessarily indicate that students' test score was going to increase, because some students may not need as much time as other students, and their needs vary. And also, 22 students, more students scored above the median compared to fall and spring MAP scores. And here's a recap of my results again. This shows the spring and fall scores, the median, and the number of students who scored above the median. And here are the results from my surveys. And next we have the results linked to my literature. So I found very few studies that showed that technology did not make a difference in students' achievement, whereas more studies show that the appropriate use of technology provides a promising direction for children learning math. So the majority of the sources that I found, they all are pointed towards integration having a positive effect on students' achievement. And then when I look at my student survey results, they were overall positive compared to a source that I shared from Nigen 2016, from 2006, and students felt like that they enjoyed using computers in math classes. They felt smarter. They felt like the problem solving process became easier. Also, they said that computer math gave more clues, more information, and practice. Was easy to identify the right or wrong answers, and was exciting to see the immediate scores. So overall, the integration of technology had a positive effect on their learning and their attitudes. It's been fun. Thank you for this opportunity. I hope you enjoyed it. So the implications I have for future practice in the near future would be, it would be interesting to conduct this study with a control group and an experimental group. And I would like to use a comparison method. For instance, I would like to compare a class, both classrooms having math teachers, and one class did not use Study Allen versus another class that did use Study Allen, and compare those scores. And also I would like to compare teacher-led instruction versus Study Allen independently. And again, compare those two scores and see if technology made a huge difference. So overall, technology does have a positive effect on student achievement and their perceptions. And very few studies have pointed out no significant difference due to lack of technology and students' ability to use the technology. So the action research process has been fun. I learned a great deal. Thank you.